over here we have a problem which says that the frictionless piston cylinder assembly and a rigid chamber both contain 15 kg of the same ideal gas. So, let us maybe draw this. So, we have for example a piston cylinder assembly which is frictionless, and here we have a rigid chamber. Okay, it is not insulated, it is rigid. Both have the same quantity of gas. So, this 15 kg, this also is 15 kg gas inside. The gas is at the same temperature and pressure in both of them. So, temperature, I am going to call this as A and B. T1A is the same as T1B. Pressure initially in A is the same as pressure in B. The molar mass of the gas is 25 kg per kilomole. So, the molecular weight is 25 kg per kilomole. We want to increase the temperature of the gas in both the systems by 20 degrees centigrade. So, the change in temperature in both of them is 20 degrees centigrade. What is the difference in the heat that has to be supplied to the two systems if the expansion in the piston cylinder happens at constant pressure? Here we have constant pressure expansion. Here it is a rigid chamber. So, volume is constant or specific volume is constant. So, the question is, what is the difference in the amount of heat which you have to give for the same delta T change in temperature? So, what we see is that over here we have heat transfer at constant pressure, and the other one we have heat transfer at constant volume. So, let us first take the constant volume case. The amount of heat transferred we can find out by first writing the first law. So, from the first law we have dE is Q minus W, or Q is essentially dE plus W. This system itself is stationary. There is no change in potential and kinetic energy of the system. So, I can also write this as du plus W. This, in the case of this chamber here, it is a rigid chamber. There is no shaft work, there is no electrical mechanical work. So, W is 0. So, essentially Q is essentially du. So, Q is du, that is equal to mCV into dt. So, we know the molar mass, we also know the mass, it says 15 kg. So, this is we have 15. So, we have mass is 15 into Cv into 20. So, this is the amount of heat in the rigid chamber in B. For the system A, we again have du plus W as Q. This undergoes a constant pressure process. So, we can write this as m into Cp into well, what we can first write it as, we can write it as du plus Pdv. The work which is only due to expansion work in this fashion, it is happened at constant pressure. So, we can write this as in the same way in which we used to do earlier. We can write u plus Pv, because this we can also add a Vdp here. dP is 0. We can also add Vdp, because dP is anyway 0, we are just adding 0, and then that is d of u plus Pv, that is essentially dH, that is equal to m into Cp into dt. So, that is m, which is 15 times Cp into 20. So, we have this is the Q added in A. We are asked to find out difference. So, we have 15 Cp into 20 minus 15 Cv into 20, which is difference. So, difference in heat added is Qa minus Qb. So, that is 300 into Cp minus Cv. But what we are given is the molar mass. Molecular weight is given as 25 kg per kilomole. So, we can find out R. So, that is 8314.5 divided by 25, which is 332.58 joule per kg Kelvin. So, Cp minus Cv we know is R. So, this is essentially 300 times R, because Cp minus Cv is R. So, now this is 300 into this, which is essentially 99.77 joule, sorry 99.77 kilojoule. I have already taken a factor of 1000 away. So, this is the difference between the two. So, what we see is, in the case of A, we are giving a lot more heat. In the case of B, we are giving a lot less heat for the same difference in temperature. So, the reason of course is that over here we need to give only a small amount of heat, because any heat we are giving goes in increasing the temperature of the gas. In this case, some of the heat we give goes in increasing the temperature of the gas, whereas the rest of the heat which we give is used in doing work against the surroundings and expanding the gas. So, only some of it effectively increases the temperature, the rest of it increases the volume and does work. So, for the same increase in temperature, we need to give a lot more input in the case of the constant pressure process, where work is being done, and a lot less input for the constant volume process, where only thing which is being done is increasing the internal energy. So, here some of the energy goes to increasing internal energy, some of it goes doing work. Here everything goes into increasing the internal energy. So, that is the difference which we see.